Hey guys, so I got a question from Richard here on my YouTube channel, and he wanted me to discuss possibly animation it looks like and the context of how an assembly is formed. His question specifically, or his comment rather, was regarding animation of an assembly. The concept of assemblies and the related parts within are confusing. Would you please explain this and how the parts are properly filed as the assembly is created and animated? I really appreciate your efforts to show everyone your expertise. Thank you. Alright, Richard, if I understand your comment correctly, I'm actually going to open up one of my assemblies and walk you through how it's put together and the hierarchy of the assembly tree. So let me get something open here. Okay, in my file structure you'll notice I have two folders. I have assemblies and I have components. This is ultimately personal preference. You can actually keep your drawings, your part files, and your assemblies all in the same directory. They do not have to be segregated, but when I'm going through and I'm looking for specific parts that I already know are not assemblies or drawings, they're just parts, I separate them out because it's just my organizational method. And that happened out of habit from the older versions of SolidWorks before they introduced these toggle filters down here. And what these do is, if you go into a folder and let's say you want to look for just assemblies in this folder, you can toggle these off and you can see there are no assemblies in this folder. But if I toggle the parts, all my parts show up. So before they didn't have that. You actually had to come in here and decide what you wanted to filter for, and most users that was just, not really that convenient. Hence why they added the buttons later on. But as a habit, I've just segregated these out from older versions. But anyway, let's get back to an assembly that we can open up and discuss Richard's question. I'll open up the main assembly here, and with assemblies there's a component level, which is your piece parts. There is a subassembly level, which is any assemblies you put together with components, and then those assemblies form a main assembly. So right now I am opening a main assembly, which means it is the top level assembly of all my parts and subassemblies. Okay, apparently it's not finding some parts, so I'm just going to let them be suppressed for now. Okay. Alright, we're all loaded up. And as you can see, we have an AK rifle here. Almost all my models are rifles, since obviously that's what I design and that's what I build. So, alright, if you look at the feature tree over to the left, you'll notice that I have a subassembly for the receiver, which is highlighted in blue now, a subassembly for the barrel, a subassembly for the selector plate, which is actually suppressed at the moment because it's not finding these two pieces, which I'll fix later. Subassembly for the magazine. Now, one thing that you can do inside of a main assembly is you can make main or subassemblies flexible. And what I mean by that is if you have mates, like let's say I want this trigger to move, and that's going to do that right now because it's not actually part of my receiver assembly. So if I do that, and I'll select these two items from my feature tree, right click, and expand my menu. We're going to do form new subassembly here. Hit OK, OK. Alright, so now there's my new subassembly, and you'll notice my trigger no longer moves like it did before. That's because it's now absorbed into this new subassembly I created with the receiver. And what happened was the mates that control the trigger movement have been also absorbed into that subassembly. So what I need to do is tell the main assembly that it's allowed to control the movement of the subassembly. So I'm going to go up to the I'm going to right click the subassembly I'm interested in, and I'm going to click component properties, and then you'll have a few options in here. You don't really have to worry about any of these unless you have configurations set up for that subassembly. What we're interested in over here is solve as. Right now it's set to rigid. If I check flexible and click OK, now the mates that are nested inside of this subassembly, any flexible mates are now flexible at the top level. So now if I grab my trigger, it moves again. And what happens is if I move it in the main assembly and then I open up the subassembly, once it rebuilds, let's get rid of that. Ah, okay. So it's actually still seeing the mate from my main assembly, but it was frozen in space because I brought this piece in. So it actually doesn't have a mate relative to this subassembly yet. So this isn't really a good example, but I think you get the idea. Yeah, I'll discard the changes. Close. And we'll just not save any of that. Okay, so let's just make a couple models quick. And we'll do let's make a rail. Set up my dynamic mirror. We'll make this construction geometry. Oops, need a line there. Okay, so there's my rail. I'm not going to worry about dimensions or anything. And I'm actually going to copy that portion of the sketch there. And then I'm going to go ahead and extrude this. Let's make it 10 inches. Okay, so this will be my rail, and we'll save that. And do I have a folder? Let's do this. I recently reformatted my computer so my folders aren't all where I like them yet. And we'll just save that as part 1. And now I have part of that sketch copied. So I'm going to start another sketch, paste the piece that I copied, and we want to preserve the size of this, so I'm just gonna move it instead of trying to move it around, or I'm gonna use an actual move instead of dragging it around and trying to position it. And then actually I could just do this. Let's do offset, and that looks good. Cap these ends here. Extrude this. Let's make this 2.5 inches. Then I'll save this. Part 2. Okay, so now I'm going to take my rail. We're going to make an assembly of it. Okay, now here, if you just click in space, it's going to drop your model anywhere. If you don't click, leave it blank, and you go up to the check mark with your first component highlighted, it's automatically going to drop your part in space relative to the origin. So now the origin of your assembly space and the origin of your part are on top of each other, which is good. We like that. It saves a lot of headaches early or later on in the assembly stages where you're going to mate parts together. So now I'm going to go back to the assembly tab and click insert components, add part 2, and that you can just drop. Let it float in space because we're going to constrain it to the other piece using mates. So now you go up to the paperclip mate button, and first thing I like to do is get it to the planar position that I want it to sit on using this. And you can mate this several different ways. That'll all do the same thing. And out of habit, I like to just mate with planes first to keep things symmetric. So the right plane bisects my rail here, and the right plane also bisects my slider, which is now positioned center to center. And then I can take the top, mate it to the bottom surface, mate it to the top of the rail. And now you can see I have a slider. But you'll notice also it's not constrained to anything. So what I'm going to do is add a limiting mate, which is under the advanced options, and it'll be a distance constraint. So I'm going to put 0 in here for a second, and then click this face and this face, 0 it out, and then I know that the maximum distance it can travel is 7.5 inches if I want this face to run flush to this face. So in my maximum value, I'm going to put 7.5, enter, and to test that, I'm going to type it up here, move my slider, and there's its extent. So it goes from 0 to 7.5 inches. And I'm going to hit the check mark and the check mark twice to get out of mates. Now if I click it and drag it, it's locked to those two positions. It can only go so far. Now, let's do something else. Let's open this back up, and let's add a hinge feature to the top of this. I'm going to do that by just creating a slot feature. Actually, no. I'm going to add a, oops. Closed my sketch, oops. Right plane, there we go. Okay, circle for where I want my hinge to be located. And I'm just, drawing whatever size here, doesn't really matter. Let's make it 0.25, and then we'll do, offset. Make some tangencies here. And then we'll convert this edge, because we want to use that. I'm going to make these two lines collinear. Now I'm going to trim the extra that I don't need. And I'm actually going to not make this tangent. I want this to be floating off of that edge a little bit, so I'm just going to drag my circle up. And then I'll use a, actually yeah, I don't even need that, I'll just throw dimension on here. Oops. Another 0.25, that looks good. And do an extrusion, and I want to do mid-plane because I want it to be center. So I'm going to do mid-plane, and then let's make it an inch, half inch. Okay. Now I need a piece that's going to hinge on top of there, so I'm going to do File, New. Start a sketch on my right plane, and oops, I know my hinge diameter is 0.25. Let's do an offset of another 0.2. Oh yeah, we can only go so far. Let's do 3/16. Oops. Okay, then we'll draw some kind of a feature that swings out off of that block. And then trim the extra that I don't need. Let's do another mid-plane extrusion. Make this, that's probably too wide, 2.5. We'll do 1. And then I'm going to sketch again on the right plane. And cut out an area for the hinge to sit in. Oops. Mid-plane extruded cut. Okay, so now I'll save that. Part 3. Okay, so now what I'm going to do is I'm going to do a new assembly. Excuse me. Okay, so I'm in a new assembly now. I don't have a part that I can just simply drop in space. But what I want to do is use part 2, hit the check mark, and then add part 3, my hinge piece. I'm going to mate the right planes together, right plane and right plane. That centers the pieces. Then I'm going to do a cylindrical mate, or a concentric mate with the 2 cylindrical faces. Check that. And you'll notice I have a bit of a collision there. So what I'm going to do is go back and edit this part. And let's just make this so I know it'll clear. Save it. Okay, so now we'll rebuild this, and you'll notice now I don't have a collision. So now what I want to do is set a mechanical mate in here that limits the angle that this can pivot. So I'm going to select this surface and this surface and zero them out. And it's in the wrong direction, so I'm just going to flip it and I want it to go 90 degrees. So now I'm going to test my 90, which is good. I like that. Close it out. Now if I drag it, it has a 90-degree limit. So we'll save this assembly. Rebuild and save. And assembly 3 is fine. Now, in my other assembly that I have open on my slider, here's the piece part that I put in here originally, but I want to add that subassembly to this and replace this. So what I can do is I can right-click part 2 over here, and let me fix this so I can have the things that I like showing on here. Okay, I can right-click part 2 and go to replace components and choose assembly 3. Hit OK, and it's going to have some mating issues because it no longer sees that as a part. It sees a new new assembly being introduced, so I'll just close that. It does see those mates, however, which is good, so I'm going to accept that. And now if we drag it, no, it is seeing those mates. Let's see what the problem is. Oh, it just needed a rebuild. Okay. So after it rebuilt, it corrected itself. Alright, now you'll notice if I try to grab that piece that I want to move, it's frozen. It's stuck because I'm now in an assembly above that. I'm in the main assembly where this is a subassembly. So what I need to do is right-click it, go to Component Properties, change it to Flexible, and hit OK. Now, it will hinge. It's using the mates within the subassembly, and it will also still slide, which is the main assembly feature. And we could animate this. Let's see how much time I've got here. We're almost at 30 minutes. I could animate it quick. You'll click the Motion Study tab underneath here, and I'll do an animation. There's a difference between motion study and animation. Animation is key-based, and you control the movement of the part, whereas if you do a motion study, you can add physical limitations to the part. You can add physics to the part, such as gravity. You can tell motors to act on it. You can tell springs to act on it. You can tell parts to collide. So we're just going to do a simple animation of, right now, let's make our view isometric. And at 8 seconds, I want this piece to be at the end of the rail, and I want the hinge to be up 90 degrees. So in my keys down here, I'm going to click out to 8 seconds, and that's going to be my play time. I'm going to drag my piece to where I want it to be positioned at 8 seconds. So at 8 seconds, I want it to be at the end of the rail. And you'll notice it automatically drags out the animation key for 8 seconds. But it only does it for the assembly 3. If you'll notice in here, there's nothing, the other parts don't have an animation displayed yet. So now I'm just going to simply drag this up. Boom. There's the key. Now if I play it from the start, over 8 seconds, that's not exactly what I want it to do. You'll notice it snaps up at 8 seconds. So I'm actually going to have it calculate what I want it to do instead. And now it's giving me errors. Let's see what's going on here. Alright, let's start over. Let's delete these keys. Go up to 8 seconds again. I'm going to move this up and pivot this back at the same time. and then calculate. And it still doesn't want to move it. Well, that's an interesting anomaly. I'm almost willing to bet that for an animation, it needs to see those mates top level in order for that to work. So, I'll do another video of that sometime, of actually animating some objects, which is actually kind of interesting and a lot more involved than I can show you in a few minutes. So, we'll cut it short right here, and Richard, I will notify you that this video is up, and let me know if this answers your questions. Anybody else, I hope this helped you out, even though I know this was specifically geared towards Richard. If you guys have any other questions or anything else you need to see, I can always expand on this one and update it. So let me know what you think in the comments, and thank you to everybody who's subscribed so far. I have definitely been slow lately uploading new videos. The 1911 tutorial's kind of at a standstill at the moment, just because I haven't had enough time to really delve back into it and get a lot of those parts modeled and actually demo the modeling again, because the simple parts are out of the way and the harder parts are up next. So stay tuned for that when I start modeling that tutorial again. Other than that, any other basic demos you'd like, such as this, please let me know. If there's any kind of specific parts you'd like to see me model, just give me as detailed a description as you can, and I will try to do it. I know it's hard when you've got an idea in your head, but there's not necessarily a print for it that you can just send me and say, hey, how can I model this? So just give me as much of a description as possible, and I'll try to walk you through modeling whatever kind of object you're looking at. So I hope this satisfies you guys for now. Stay tuned for some more.